So we're looking for the for the values of the constants for m, b, and r, so that mx plus b equals, mx plus b plus e to the rx is a solution to this differential equation. So it's kind of similar to that one we did with we wanted y equals mx plus b to be a solution to it. We're going to use kind of the same general idea. So what we will do to start with is just say that the value of our derivative, 3x plus 2y plus 1, should also be equal to the derivative of this. So if we take the derivative of y equals mx plus b plus e to the rx, we end up with dy dx is equal to m plus r e to the rx. And since that's also equal to dy dx, we'll set that equal to 3x plus 2y plus 1. And then in order to get rid of that variable of y, we're going to go back in and replace all of the y's. As I just have the single y here, we're going to replace that with what y was equal to. So we've got m plus r e to the rx equals 3x plus 2 times mx plus b plus e to the rx plus 1. And let's simplify that out a little bit. All right, so now we got that distributed through. So now we're just going to sort of match up what's going on here. We've matched up our different variables. And the one thing that we probably want to note here is that if r were to be equal to 0, if r was equal to 0, we'd be losing this r e to the rx term, and this term over here that has an e to the rx would just become e to the 0, so that would just go away and we'd just be left with constants. So we have to take into account what happens when r equals 0 to start with. So if r equals 0, we should end up with m equals 3x plus 2mx plus 2b plus 2 plus 1, so plus 3. And we should be able to factor out the x on this side. So we're going to say that, let's see, m equals 3 plus 2m times x plus 2b plus 3. And that should tell us that 3 plus 2m equals 0, since there are 0 x's on the left side and 3 plus 2m x's on the right. And so that would give us m equals -3/2. And if m is -3/2, r is 0, as we said. And then our b value, 2b plus 3, needs to equal m. So 2b plus 3 needs to equal -3/2. And if we, let's see here, if we subtract 3 from that, that's going to give us, what's that going to give us? -9/2, so -9/4. And then, so that's one possibility. And then another possibility would be if r does not equal 0. So if r is not equal to 0, then we're still left with this m plus r. I'll rewrite it over here. M plus r e to the rx should be equal to 3x plus 2, we're going to take out we'll take out the x from this again. So 3 plus 2m times x. And then plus 2b plus 1 and plus 2e to the rx. And so if we go and do it this way, we can take a look here that we have r e to the rx's and 2 e to the rx's, so r must equal 2. And same thing over here with the 2m plus 3 needs to equal 0, so m is still going to be negative 3 halves. And if m is negative 3 halves, we've now got negative 3 halves equals 2b plus 1 instead of 2b plus 3. So we'll subtract the 1 to make negative 5 halves and divide by 2 to get b equals negative 5. And so that would also work. Any questions there? You could have given this set of answers, or you could have given this set of answers, and either one would be good. R equals 2, because we've got 2 e to the rx's and r e to the rx's on opposite sides of the equal sign. So the number of e to the rx's on both sides must be equivalent. Kind of like how we separated out when we're doing partial fraction decomposition. Not a problem. Anybody else have any other quick questions they want to go over before we do the quiz?